I hope you've been good so far with the lecture videos and I hope it's been helpful as well. Okay. In my last video, I did an example on real and distinct systems of equations. When I say that, I mean that the eigenvalues from the system was real and distinct. In this example, I'm looking at a case where the eigenvalues are repeated. Just one example, and in all other cases you can survive. So assuming I have a simple system as this. 9x1 plus x2 to solve. Don't forget, we are still looking at homogeneous aspects of the system. Okay. So it means I can write this system out as x1 prime, x2 prime is equal to, the coefficients matrix here becomes simply that the unknowns are x1 and x2. There's no J part, it is equal to 0. So this is the first thing I do. Write out your coefficient matrix, write out your matrix. When you are done, you find your eigenvalues. So these are the simple steps to follow. Eigenvalues means I'm going to find the determinant of some a minus lambda I equal to 0. I'm going to just write the answer straight away. I'm assuming that from the first video you would have found how to solve eigenvalues and eigenvectors. So if I find the characteristic equation, I'm going to get lambda square minus 8 lambda plus 16. And in that case, the root becomes lambda 1 to be equal to 4. There's a repeated root. Let me just help. There's 7 minus lambda, negative 1, 9, 1 minus lambda. If I find the determinant of that, I'm going to get this. And that is a root. So we've classified this as repeated root. Now the next thing is to find the eigenvectors. So 1, 2, 3. Find your eigenvectors. An eigenvectors is for when lambda equal to 4. It means I'm going to have 7 minus 4, that is 3, negative 1. 9, 1 minus 4, that is negative 3. Some v1, v2 is equal to 0, 0. Don't forget to find eigenvectors, giving us a minus lambda I v is equal to 0. I'll simply, if I should divide through by 3 for this row 2, you see that it will be as 3 negative 1, just as the first row. If you want to use row echelon form, you know what to do. Other than that, I just pick the first part of the equation. It means 3v1 minus v2 is equal to 0. This implies that 3v1 is equal to v2. So whenever v2 is 1, you realize that your when v1 is 1, you realize that your v2 will be what? 3. It means eigenvectors here is 1 and then 3. Don't forget this eigenvectors, and so anyhow to get it. Now if I want to write the solution, I'm not done, because it's lambda 1, 2. I have to find the second eigenvector. It is still at lambda equal to 4, but in this case it's going to be as a minus lambda I of v2 is equal to the v1 I had. For the first case, it is just a minus lambda I v is equal to 0. Now I have found for v1, so I can use that to find capital V2. These are capitals. Let me say v1. So this is going to give me the same matrix. I have 3, negative 1, 9, negative 3. Let me use u1s to replace v2s. It's equal to 1, 3. This is to tell you that if your V1 is wrong, you are going to get V2 to be also wrong, and you want to avoid this scenario. Now let's see. If I pick the first part of the equation, I'm going to get 3u1 minus u2 is equal to 1. Or you can also choose the second row. This means that 3u1 is equal to u2. So if I pick u1 to be 1, you realize that u2 will be 3. If I'm correct with this. No, that's not correct. It is not equal to 0, it is equal to 1. So it means 3u1 minus 1, is equal to u2. Or someone will say 3u1 is equal to 1 plus u2. Any way you want to write it out. But I want to avoid fractions, and so I'll go by this first case. This means that if I set u1 to be 1, u2 is going to be 3 times 1 minus 1. That'll give you 2. It means the eigenvectors here, v2, is simply 1 and then 2. So I'm done solving for v1 and then v2. So I can write my solutions out as a fourth step. The solution becomes c1 v1 my lambda t plus c2, it's going to be the multiplicity of t of the first eigenvectors plus second eigenvector of your solution. So let's simply do the substitution. v1 was given as 1, 3. E lambda t, lambda is 4, plus c2 t of 1, 3 plus 1, 2 of my second, or the same lambda 4t. You can leave your answer this way. You can go ahead and then simplify. Assuming I want to still simplify this, I have this term c2, that'll be t plus 1, 3t plus 2 e4t. So this is my answer for the repeated root. In the next video, I will take that of the complex root. Someone will still want to further simplify. It means I can factorize e to the power 4 out. I have c1 3c1 plus c2 t plus 1 plus c2 3t plus 2. This is a further simplification of the solution. So that is a matter of choice. And the last example will be on the complex root. Thank you.